We're going to begin this lesson by trying to simplify each of these radicals as much as we possibly can and leaving our answers in exact form. To do this, we want to use the perfect squares that we see above and try to factor out numbers such as these perfect squares. Let's take a look at number 1. What perfect square can we factor out of 50? We can factor out 25. So I'm going to factor out the square root of 25, and we're left with the square root of 2. Now we can take the square root of 25, which is 5, and we're still multiplying it by the square root of 2. And that is our simplified answer. 18. We can factor a perfect square out of this. We can factor the square root of 9. And we're left with the square root of 2. The square root of 9 is 3, and it is multiplied by that square root of 2, which is our final solution. 24. What perfect square can we factor out of 24? We can't factor 25, it's too big. 16 isn't going to work. 9 isn't going to work, but we can factor a 4. So I'm going to factor the square root of 4 out of there, and I'm going to be left with the square root of 6. I can't factor any perfect squares out of 6, so that's going to stay all by itself, and the square root of 4 is 2, so we end up with 2 times the square root of 6. Are there any factors that we can factor out of the square root of 3 that are perfect squares other than 1? No. So the square root of 3 is simplified as it's going to get. How about the square root of 47? Well, 47 happens to be a prime number, so there's nothing we can factor out of there. So we just end up with the square root of 47. Let's start looking at a few more complicated examples. We want to simplify the square root of 50 divided by 2. Well, we already simplified the square root of 50. We got 5 times the square root of 2. Now we're not allowed to have radicals in the denominator, so this is as simplified as it will get. Number 7, we already simplified the square root of 18, and we ended up with 3 times the square root of 2, and that's all over 6. There's a common factor between 3 and 6. We can divide top and bottom by 3, and we are left with the square root of 2 over 2. Number 8, we already simplified the square root of 24, and we got 2 times the square root of 6. It's all divided by 4. There's a common factor in the top and the bottom. I'll divide top and bottom by 2, and we end up with the square root of 6 over 2. And now for some even more complicated examples. This type of example we're going to need to know in the next lesson, so it's important that we know how to simplify these. We know the simplification of the square root of 50. We already have it up here, so I will take that. 2 plus 5 times the square root of 2 over 2. There are no common factors, so this is a perfectly fine answer. But if you wanted to, this is not required. I just want to show you that it is not incorrect either. We could split this into 2 separate fractions being added together. We end up with 2 over 2 plus 5 times the square root of 2 over 2. 2 over 2 is equal to 1 plus 5 times the square root of 2 over 2. That is also an acceptable solution. Both of these would be considered correct. So don't feel like you have to do the extra work. I just wanted to show you that that option is available. All right, 2 minus the square root of 18. 2 minus 3 times the square root of 2 from above over 6. This is a perfectly acceptable solution, but if you wanted to, you could split out the fractions. And then you can simplify further, and we would have 1/3 minus square root of 2 over 2. Both of these are correct solutions. 8 plus the square root of 24 over 4. We factored the square root of 24 earlier, so I'll go ahead and write that. Now we can simplify further because we can factor a 2. Whoop, that should be a 4. We can factor a 2 out of the top and bottom. So we end up with 4 plus the square root of 6 over 2, which is a fine solution. But you could also have 4 over 2 plus the square root of 6 over 2, which when simplified becomes 2 plus the square root of 6 over 2. This is correct. This is also correct. Finally, number 12, negative 4. The square root of 16 is a perfect square root, so we can take that square root, which is 4, and divide it by 12. We end up with 0 over 12. 0 divided by any number that is not 0 gives us 0 as our final simplified solution.